streaming. I have the creepy screen for those of you who remember it from last time. It's not visible yet. And I'm going to start a screen share myself here and explain how this is going to work. So you should be able to see our syllabus. Is that up? Not yet. A few. No? It's a should be a web page. It's purple. Is that up now? Okay, yeah. Each of my classes is a different color. That way when I stare at it, I know what I'm looking at. That's my system. So it's very like HTML from 1999, but it works for me. So all the material from this class is going to be on this website. All of the lectures, I'm going to post videos because I know that everything is crazy right now. And despite your best intentions, you may not be able to be here every time. My hope is to record all of the sessions. But what is going to be recorded is just my voice and the screen share. So I have two monitors set up. One has the things that are going to be streamed, and the other is where the Zoom window and my microphone, not this is my microphone, webcam is. So you guys won't be on the internet, just me. So what that means is that if you have questions, I'm going to have to try to remember to repeat them. That way we can hear the question on the recording as well as my answer. So after the videos are done being processed, they'll be posted on this page next to wherever the lecture is on each day. This website, the only thing that's not going to be on here in terms of course materials is your readings. Those are going to be inside Icon. I have uploaded a compressed folder, a zip folder, that has all the readings that are currently on the syllabus, so you can download them all in one shot. Speaking of which, go scroll down here about that stuff. There is a course textbook, but it is owned by the university libraries, which means that you can read it for free online. It allows you to save some of the pages, but not very many. All of the other readings are going to be inside Icon. And there are a lot of readings. I'm just going to warn you. This class covers a lot of ground. And because I can't cover everything in the level of detail that I would want to, I feel compelled to give you extra resources. So these articles are things that, like, if you want to know more about a particular topic or you found yourself struggling to understand it and need to sit down with it, I've picked things that you should actually be able to read. Like that was my number one criterion is like, is this in English? Like even if there's Greek letters and matrices, is the rest of it in English so you could actually understand it? I picked readings that met that goal. So each class has at least one reading, sometimes more. You don't have to worry about having them done before the class shows up. They just go with whatever the topic is. And I intend them to be resources for you so that you can not only understand what's going on, but also hopefully be more aware of current work. So I added, I think, maybe 5 articles that have come out within the last year or two to these topics, just so we can try and stay as current as possible, in addition to the textbook and chapters of other books. Terms of timing, we're going to meet on Zoom 2 to 3:15 Tuesdays and Thursdays. And I have office hours that start directly after this class. I have a class that meets before this one from 12:30 to 1:45. So if you show up too early, you might get to hear the tail end of the previous class, but I just have this meeting room open throughout the whole afternoons on Tuesdays and Thursdays. Are any of you at home with children right now? Couple people? Yes, say Megan's at home with children. How old are your kids, Megan?
They are 2 and 6.
2 and 6. Wow. And is someone keeping them alive while you sit here?
Um, yeah, I hope so.
Oh, you hope
Yeah.
so. Say, are you keeping them alive? Like you're sitting here listening and watching out of the corner of your eye.
No,
Yeah,
no, they're fine.
they're fine. Great. Well, I am sensitive to that, the needs of childcare. I have a son who's 5. He is at school. I am so very happy. He started kindergarten yesterday. He's at the Montessori school where he's been the past couple years since we've lived here. They have figured out a way to stay open. Everyone is wearing masks, including the children. Believe it or not, I visited with the teacher at the end of the day yesterday. She said they kept their masks on. It can be done. So that gives me this much hope that his school might actually stay open. If that changes, if he is running around here and that has any consequences for you guys, I will let you know. It's possible that I may have to move office hours or something like that if I don't have childcare, or you may see him playing Minecraft in the background while I talk to you. One of the two, whatever. Um, does anyone here, by the way, play Animal Crossing? Okay, yes, a few people. Would anyone be willing to explain to me why it is fun? Anyone?
Like right now?
Yeah.
Yeah, I can because I love it. I've been playing it since it was on the GameCube. It is just happiness. That's all it is. That you have little animal friends who are your friends, and they're always happy to see you. And you catch bugs and fish, and then you go and you just talk to your little friends, and you pay off your house. And yeah, it's just really fun. It require a lot to
Okay.
think about.
Yeah, so my son is addicted. So I spent a very long chunk of my summer watching him play Animal Crossing and reading what the characters say because he can't read yet. So I want him to learn to read for the sole purpose that I don't have to sit there and read what they say anymore. I want him to become able to do that.
Who's his favorite villager?
I have no idea because he keeps restarting his island. He
Oh.
keeps like just nuking it and going back to square one for reasons that are unclear to me. The other thing he likes to do, by the way, you can time travel. Did you guys know this in the game? You can change the system clock. It will go from the year 2000 to 2060. And so like if you build something and then it's like it's going to take like a week for it to be finished, you just fast forward a week and it's done. It's amazing. So, okay, so this is just a key to my life. This is what my summer's been doing. I'm glad that you have found some entertainment. Hopefully this semester will be entertaining. This is our chance to feel like people and not be a mom for a few hours. So sorry, Megan, you're still a mom for these few hours, but I'm happy to not be a mom for right now. We're going to talk about what I call, this class is called Factor Analysis and Structural Equation Models. It's a lot of ground. I have, to keep myself from rambling too much, a few introductory slides on PowerPoint. Let me pull those up for y'all. They're purple to go with the rest of the color scheme of the course. Can you all see that? All right, thank you. I love the enthusiastic nods and thumbs ups. I appreciate that. So, the big picture of what we're learning is what I call latent trait measurement models. That's an acronym you will see several times. It encompasses everything that we're going to do and then some. It's a big world out there. So, why are we here? What to expect? This is another chance for you to expand your knowledge of quantitative methods more broadly. Let me check to make sure I'm still streaming. I'm paranoid that the stream is going to stop without me knowing. Okay, it seems to be going okay. Great. So, models are the lens through which you view research. I strongly believe that learning new quantitative methods makes you think about your research differently. If all you knew how to do, for instance, was an ANOVA, an analysis of variance, then the only kind of research questions you would think to be able to ask is about group differences. Are these groups different in this outcome? Are these groups different in that outcome? Once you learn new models, you learn new ways of thinking. And this class is different than the other classes that I teach. And I say that because a lot of you have been with me for those, because it's focused primarily on measurement. But spoiler alert, measurement models are statistical models. This is still a stats class, even though it goes under the heading of measurement. They are statistical models that we're going to be learning for the purposes of confirming hypotheses about measurement and then using the constructed variables to answer research questions. So it's more fundamental than some of the other classes because you're dealing with data like sort of that's done. This is on the front end. Like if you are trying to create a new measure that hasn't been tested before, what do you do? How do you know if it's any good? Right? What are the steps that you would go through to be able to have some kind of confidence that you've measured something useful and that you've measured it well? That's what this class is about. So because measurement models are statistical models, a lot of the things that you've learned elsewhere are going to be relevant. which is why I said in my introductory email to all of you guys, I just need you to have a handle on regression, right? If you know what an intercept is and a slope is, we can start from there because measurement models are regression models. That's the truth. Things that we're not going to do. We're not calculating things by hand. There will be some stuff that we do in Excel or that we'll have routines to do in software, but we're not getting out sums of squares and all that stuff. No, that doesn't apply here. It's not there. We're not deriving formulas. This class is going to be very applied. If you were taking a class on latent variable models from the stats department, it would be a very different class. My goal is to be able to give you techniques that are going to help you in the research that you do. It's a very pragmatic goal to understand these models, to be able to use them to further your own work. That's my goal here. We're not going to derive stuff, we're not going to prove stuff, and we're not going to memorize stuff. I'm going to show you how to use software to get the answers that you need. And most of the techniques that we're going to talk about, hand calculations aren't even possible to do. You need iterative algorithms anyway. So any of the things that might make you nervous about taking a stats class, don't worry about it. We're not going to worry about it. We do have a lot of language to learn. So there's a lot of notation, there's a lot of vocabulary. And what makes this class more interesting than most is that the exact same idea has a completely different set of terms, words, and notation depending on where you are. So if you learn about a class of latent variables from psychology, that's very different than how it's talked about, say, in education. And so I'm going to try to tie together these different worlds and different words, but you'll see this as a common theme. Like, oh, by the way, we have this term. Now the term is called this, but it's the same idea. So I teach this in a very integrated kind of way rather than a siloed kind of way, focusing on one model or another model in particular. What you're going to do, you're not going to take tests. I don't believe in tests. I just don't. I don't want to train people to spend 3 hours dumping their brain only to forget the material the next week. That's just not what I'm about. I'm not going to dwell on historical techniques. So the first 2 weeks of this class are going to be a very quick overview of techniques that I would call, there's a term that's used by Rod McDonald. He was a scholar in the field of measurement, has a great book that I have a couple chapters on your list for, but he used the term device. A device is something that you use because you have to, because you're stuck with it, right? Exploratory factor analysis is a device. Alpha is a device. So the first few weeks of this course are going to be a quick tour through antiquated stuff that we don't need anymore. Then we're going to spend our time on the so-called modern stuff that's actually not all that modern. In contrast to typical SEM courses, we're going to deal explicitly with models for variables that are not normal. Because most of the items that people collect on surveys are either categorical, so there's just different options, or ordinal, right? There's like, how much do you agree? Do you agree 1? Do you agree 2? Do you agree 3, right? Strongly agree, slightly agree, neutral. Like those are the kinds of variables that people collect. And so I want to make sure that you have models in your toolkit for those kinds of variables as well. What you are going to do in terms of planned work is a combination of two things, formative assessments and homework. So what I call formative assessments are called quizzes in Icon. I have planned 6 of them, about every other week. The idea is to give you something to do structured review with. So I'm going to put up big picture questions that I would hope you can answer mostly off the top of your head. If you can't, then that gives you an indication as to what you need to review. And each of these is going to be due on a Monday night. That way, the following Tuesday morning, I can look over your answers and I can see if there's any common points of confusion or miscommunication, and we'll go over the answers in class. So for each of these, I have a total system that's 100 points for the semester. You get 2 points for doing each of these for just doing it. Doesn't have to be correct. Just making a good faith effort at completing these, you get your 2 points. So I'm not grading them for accuracy. I will read them, but that's more for me to kind of get a sense of where the class is and what I need to go back over. The other thing is homework. I have 6 assignments planned. Unlike my other classes, these are going to be of 2 different kinds. The way that I want to approach this material is show you how to do it, give you a chance to practice it. Now you do it on data you care about. So 3 of the homeworks are going to be using a custom online system. It's the same system that I use in my other classes, for those of you who are familiar. It's not available yet. I wanted to wait and see how many add drops we had to get the roster finalized, and I'll show it to you next week. Those will give you a chance to practice. And in that system, there's 2 types of questions. There's computational questions and interpretation questions. The computational questions are numbers. Like I'll ask you, enter the log likelihood for the model. And you have to enter the number and the system knows whether it's right or not. And if it's right, the number turns green. And if it's wrong, it turns red. And you get as many tries as it takes to make it turn green. So you get immediate feedback to make sure that you're on the right track. The other questions are going to be either interpretation questions or multiple choice questions about the meaning of the results. Those you get feedback on after you've submitted. So I'll show you that system next week. The other 3 homeworks are going to be on data that you care about. So start thinking now about what kind of data you'd like to play with. One of them is going to be about doing some research on a scale. So the idea is that you would take data from a particular instrument. It can be of any construct, of any context, but an instrument that's supposed to measure something. And I want you to do some research on what has been done with respect to evaluating the quality of the instrument so that you have a sense of where the research stands. And then I want you to be able to use that data to do analyses. So as the assignments get released, I'll give you more details, but just start thinking about what would be interesting to you in terms of analyses of data that you care about. So I remember, let's see, where's Kayla? There you are. You're in the top right corner of my screen here. I remember talking to you like a year ago before the Earth was on fire about data you collected maybe as an undergraduate. Am I remembering this correctly?
A long time ago.
Long
Correct.
time. So you either made up a scale or was collecting data about something?
Yes, it was for parental alienation syndrome, and it was Qualtrics data.
Okay, so items designed to measure parental alienation. Did I
Yes.
say that correctly? I'm not sure what that is, but I'm sure I'll find out more about it. That would be a lovely thing to use for this.
Ooh, okay.
So any data that you have lying around that's not like done, right? Like research that's ongoing, if you're going to be analyzing data for a thesis or a dissertation, where some of the measures are things that are not necessarily like tried and true, like you're not really sure if it measures one thing or 2 things, like it could go either way, those would be great projects. So the idea is for you to take this class as an opportunity to get structured practice to do research that you would have done anyway. So try and think about ways to fold that in. If you're sitting here thinking to yourself, yeah, I have no data, I have no idea what I'm going to do for this, I have shit tons of data. I will be happy to share with you. And yes, I tend to swear a lot. I'll just warn you. Shit ton, by the way, is a very large amount. So there's a lot of Midwestern slang in my swearing. As a metric shit ton is an alternative. I try to keep my swearing PG-13, but the occasional F-bomb if it's warranted, right? Just as the exception. So just warn you. I have a shit ton of data. So if you don't think you'll have access, send me an email and I'll be happy to facilitate finding data to do these homeworks. So because the 3 homeworks are things that you're doing that are new, they're going to be written assignments. It's going to be things where you do the analyses and you do a results section. You get to revise them. So the way that each of these will work is that you'll turn in a first draft for points. I will give you feedback. So like line by line comments in your document that tells you what needs to be fixed or what you've forgotten. things where you need to clarify something, stuff like that. And then just like if you're reviewing or revising a manuscript, you fix the things that are wrong. You use track changes so that I can see what you did, and then you get your points back. So you get one revision to go with each of these things, and you're allowed to ask as many questions as it takes to clarify what I mean by the comments. So again, trying to give you practice with skills that matter, being able to take something and improve it upon the receipt of feedback. That's a very important skill. So that's what we're going to do. In terms of my responsibilities, I thought long and hard about how to do this class, right? I figured we were going to be online. The question is, do I do it synchronous or do I just sit and record lectures and talk to an empty screen? I thought that talking to an empty screen would be so damn boring to do. Like, how boring would that be to watch, right? Just watching a video about statistics and there's like no chance to do like to interact or anything. Like that just to me sounded terrible. So this is a conversation. I have chosen this structure so that you and all the boxes here, can interact. So that means interrupt me. I'm going to talk a lot and I'm going to talk too fast probably. So stop me at any point that you have questions or just to say, can you please slow the hell down? Like put the caffeine down and just take it down a notch, Lise. Like that's an acceptable comment too. But know that you're not an interruption. You're the point. So I want to have a conversation where you get to interject. I especially love questions of things like, hey, in my research project, we're doing X, Y, and Z, and that makes me think of this because is this what you're talking about in this case? Yes. Those are great questions. Or I'm really lost. Can you just like back up and tell me what's what? Like that's also good feedback. And if you're shy, type in the chat window and anonymous questions too. That's fine. So I'm trying to keep track of the chat window. I've lost one. Okay. All right. Lexi says she loves it. Was that I swear? Is that what you love? Okay. Yes. Why not swear?
Yes, I love it.
I just keep it real, right? That's what I'm doing is I'm keeping it real. There's the version of me like when I give a talk at a conference, I don't swear, right? I put on my suit and I stand at the podium and I speak in proper sentences and I pause and I do everything that I'm supposed to do. But this is not that, right? I keep it real. Although I did make a joke once in a talk. There's an acronym in SAS that's DDFM. It stands for Denominator Degrees of Freedom. And I once in a talk made a joke that it stands for dude, doesn't freaking matter. That got a laugh. But that's as close as I've come to swearing in a talk. I would not recommend swearing in a job talk, by the way. That's not a good idea. But anyway, on here we can. So I have prepared a shit ton of material for you. It's a lot of lecture material, a lot of examples, and a lot of readings. So I have tried to make it so that you don't have to necessarily ask the Google for further information because I'm trying to give you as much as possible. That being said, I'm sure I'm not going to hit everything that matches exactly what you need to be able to analyze your own data. So don't be shy in asking for more resources if you find that something isn't quite what you need or you're not sure if it's what you need. Please ask questions. You can ask me an email. I have group-based office hours, so after this class is over, 3:15 to 4:45 this year on Tuesdays and Thursdays, assuming Huey stays in school. You can come and hang out, do your homework. You can just hang out in the background while I'm talking to people and then like pop in if you have a question and then go work. That's fine too. That way I can help as many of you as possible. If you want to have an individual meeting with me where you don't want to share my attention, schedule one. I'm happy to do that during off times. Let's see. Things that you can do then. That's the rest of this. Asking questions, reviewing the material as frequently as possible, practicing. So trying to do these things on your own data is where I eventually want you to be. And I've given you opportunities to do that through homework assignments. But if you can do that on your own in addition to that, that will help you learn. Learning on data that you care about is the best way. There's nothing I can give you that matches that. Okay. sorry, checking the chat window saying, okay, I've chosen the readings so that you can read them. There's a lot of really bad literature out there. I got to be honest with you. There's a lot of things that are written for people who already know what they're talking about. And I have deliberately tried to avoid those readings for you. And also obey the 15-minute rule. So if you're working on homework and you're trying to make the same number turn green and it's been at least 15 minutes and it hasn't worked, you need to stop. Stop, put it down, send me an email, or pop into office hours. Um, don't go ask the Google to try and figure it out, right? Here's the reality. They pay me. This is my job to help you guys. So don't feel like you're going to be a burden or feel ashamed that you haven't figured out something yet. Let me help you. Don't get frustrated and go down the rabbit hole and waste time that you don't have. So if you need help, please don't be shy. And you can have each other too, to help each other. I'm fine with people sort of working together so long as you can each do something independently if the time came to it. That's really my standard of like facilitation, not copying. Let's see. What else do I want to say here? Where's my pink mouse go? Okay, software. Eh. I've chosen M+ as the course software. This is not going to please some of you. But here's the thing I was trying to go for. I'm trying to make sure that whatever software I choose, you all have access to. And I have done that. You all should already, inside Virtual Desktop, have access to M+ 8.4. So as soon as possible, I would like you each to log in and verify that. If you don't know how to use the virtual desktop yet, I'm going to make a video that shows you how to do that, probably within this week or next week at the latest, so you all have access. M+ is hella expensive. If you wanted to buy a student license, it's $200, and for regular people, it's like $900. So it's not something that I expect you to have on your own. The license for the university is limited to 20 concurrent users. Okay, did you hear that, guys? There's 24 of you in this class and 20 concurrent users. So that means if everybody waits until the last minute to do your homework, 4 of you are going to be SOL. Do you know what SOL means? Few people know. It means shit out of luck. That is another Midwestern abbreviation. It means 4 of you will get bounced from the system. Something's dinging at me. Waiting room. Okay, there we go. Sorry. Ding dong. There's someone else. So we're going to use M+. I had to pick something. Question from the audience. How does it compare to Stata? Good question. M+ does everything that I need it to in one simultaneous framework. So the reason that I picked it is that Stata, R, SAS, and any other package, they have sort of routines. Like you can do this type of model in this routine and this type of model in that routine. And if you wanted to try and combine, that's where the software packages often falter. I would say relative to the alternatives, Stata is reasonably close to M+ in what it can do with respect to these models. It handles missing data differently in some of the models. I have, in addition to examples using M+, this class has a long history. I've been teaching this class or some earlier version of it for 13 years now at 3 different universities. It started at the University of Nebraska, then I was at KU, University of Kansas, and now I'm here. And when I was at KU, my husband, another professor in our program, Jonathan Templin, he used to teach the same class every other year. So we rotated who taught it. And when he taught it in R using Levon. So for those of you who are familiar, yes, I see some enthusiasm. Yay, R fans in here. I will, I should be able to, I don't see why not, but I don't want to promise, be able to give you links to his materials that use the exact same examples, but in R, so that you can see what that would look like. If my son's school stays open and he's not here all day long, then I should be able to come up with some Stata examples as well. So I'm going to use M plus sort of as the primary package. That doesn't mean you have to use it for everything when it comes to your own data. I hope to be able to give you resources so that you could use Stata if you want to, or R if you want to. Whether or not that's going to be sufficient for what you need depends on your exact configuration of data. I can't predict that for you. But in terms of syntax, one of the things that's nice about M plus is that it's super easy to use. There are very few terms. They love the special keys on the keyboard. So if you look above the numbers on your keyboard, like those special characters, they've used every single one of them in their syntax. So there's a little bit of a learning curve, but it's not as bad of a learning curve as learning R, in my opinion. So Megan, does that answer your question about Stata? Okay. It's different than Stata in one respect. Like in Stata, you have like a syntax, a do file that has all the different models stacked up. In M+, it's one file per model. So that's one difference. And you can get into file hell very easily if you have lots and lots and lots of files. But otherwise, the syntax is really straightforward. There is a GUI, but honestly, you don't need it because the syntax is for these models in particular is pretty straightforward. So. Even if you're more familiar with a certain package, I would encourage you to pick up as many different packages as you can while you're in grad school. Do you guys have in your CVs a technical skills section? Okay, if you don't, you need one. All of you. You have technical skills. Every software package that you know how to use is a technical skill. So any software package that you know how to use beyond like email and Office is a skill. If you know how to make Qualtrics surveys, if you know how to write HTML code, you know how to use GitHub, you know how to use R, any of that is a skill. So the more packages you pick up, the more skills you have to list. Would the base be sufficient? Yes. Yes, with an asterisk. There are a few exceptions to that it would have to depend on your particular version of data. It will do like 90% of what we're going to talk about, the base version. If you have like fellowship money, like if any of you are on grants or fellowships where you have some sort of spending allowance, buying M Plus would be a great investment because it's way cheaper as a student than it is outside of that. The way that M Plus works is that it never expires, but they put out updates periodically. And if you want to be able to keep getting the updates, you have to pay a yearly renewal fee that's $175. So you could like have your student copy of M Plus for 5 years and never have to do anything. But if you want to upgrade it, that's when the money comes in. And Stata works the same way. Like there's a perpetual license for Stata that you can get that never dies. So that's the plan, is to use M Plus. Okay, let me think. That being said, okay, yeah, everything I just said. Any of you use Amos? Yes, okay. That one isn't going to do a lot of stuff. So the Amos will get you through like week 6 of this course, and then you have to wait bye-bye. So as long as you're willing to learn something else. It doesn't have categorical indicators. That's the problem. Everything has to be normal in Amos. Same with Calis in SAS. That's the other package that I know. So, all right. Other questions on software or anything else that I've been rambling about so far? Okay, how are we feeling about the semester here? Are we feeling okay? Yeah, a little apprehensive maybe. Is there like a sideways thumb emoji? That's something my son does when he's like ambivalent. Like he'll give me a sideways thumb. Yes, I am not assuming any of you know M+. I'm going to start at the very beginning, so don't worry about that. I hope to, I'm not going to promise that this class is easy. However, historically, my students have said that it is easier than my other classes, whatever that means. One of the reasons why is that there will be no interaction terms in this class. None at all. So I know Kelly's like, what? How can we not have an interaction term? Okay, like maybe the very, very last example, 9C, I think has one, but that's it. Like it's just a little baby one. So the models are more straightforward, I think. There's just a lot there. I don't know how to describe it. It's different than the other classes, but it is a stats class too. So if there's anything that I can do to help you feel less apprehensive or about your preparation, please let me know. I'm happy to do that. All right. So three main sections of the material that we're going to cover. One is what I call sort of old school. Just kind of a here's what's been done before and here's what's wrong with it. And this is why I shoved it all into a 2-week span. I used to take more time with it and then I just decided it wasn't worth it. So that's going to include things like principal component analysis, exploratory factor analysis, and classical test theory estimates of reliability that you do not have to justify in any way. You just believe. So all of those things fall under that category. Then we're hitting latent trait measurement models in section 2. So these, if you are fitting a model that predicts responses that are continuous variables, which like never happen, but whatever, that's called confirmatory factor analysis. That's going to be our first variant of that. If you're using models to predict binary, ordinal, or nominal responses, that is known as, wait for it, item response theory, item factor analysis, or generalized structural equation modeling. So we're going to do those next. And then we'll do invariance, which is the process of trying to see whether or not the measurement models function similarly across different kinds of people. And then in section 3 is trying to put different constructs into the same model. So multidimensional models broadly construed. These fall under the categories of higher order factor analysis or second order factor analysis, bifactor models, method factors, all kinds of stuff like that, and then into the final world of path analysis and structural equation modeling. So we don't get to the SEM part till the very end, but I gotta tell you, it's going to be really anticlimactic when we get there. Because what makes SEM hard is the process of building a latent trait measurement model. Once you have that done, SEM is regression. It's not any more complicated than that. So we're going to spend our time building the latent traits because that's truly the new part. And then the very end part of the class, we'll finally get to that. If I had my druthers, this class would be 2 classes. I would do this class and sort of an advanced class that gets more into the nuances of SEM. I've never been able to do that yet, but if there was enough demand, perhaps I could someday offer a second half of this, because to be honest, this is a lot for one semester. It's one of those things where you have to go over it multiple times for it all to kind of sink in. So just the big picture there. All right, so we're switching gears after this slide. Any questions or comments? All right, so words, a little bit of history. Test theory is one of those phrases that you may hear thrown about. That's what all of what we're going to do is relying on. Other terms for this, the theory of psychological tests and measurement, or psychometric theory. I don't know why the psycho gets used for everything. I am from psychology, but I can tell you that these models get used on all kinds of traits that have nothing to do with psychology. So don't let the terminology throw you. This is really a much more general set of techniques. The idea is to use statistical models to operationalize and provide answers to problems of measurement, to be able to set up like empirically falsifiable rationales. Like, is this set of items measuring one thing or is it measuring 2 things? Like, how do I tell the difference? And what evidence is there for each of those causes? Evidence requires statistical models. So even though we're focused on models for measurement purposes, we need stats to do that. There's 3 branches of measurement that go for latent traits. You know one of these already. So let me tell you a backstory about this. Classical test theory. Have you guys heard of this before? Some of you may have taken classes on it. I know I have several students from psychology. Where's my psychology students at? A couple people? All right. If I said classical test theory, would you nod or go, huh? Anyone? Is that a huh? Yeah, it's a huh. Yeah, me too. So when I was in graduate school at the University of Kansas, Susan Embretson was there. Okay, so shout out to Susan Embretson. We got some fans in the house. Um, she is a big deal in the world of item response theory. And I took a course on item response theory from her. And the first chapter of her book that she literally wrote, it was the year that it came out, it was 2000, I'm dating myself, was this contrast of classical test theory and item response theory. And I read it and I underlined it and I read it again. And I'm like, what the hell is classical test theory? Like, what is that? Well, it turns out that all of the things that I learned about measurement and scale building as an undergraduate in psychology fall under this heading of what classical test theory is. It's the logic by which you are allowed to take a bunch of items, add them up, and claim that that total score means something. That's what it is. Incidentally, in Susan's class that semester, she did it in a seminar format where each of us was assigned a chapter and we had to present the chapter to the class. And she's the one who wrote the book and she sat there while we presented the chapter. So I don't have fond memories, given that I learned about, say, estimation from someone who read it the night before along with me. But so I hope to do a little bit better than that. But that was, I did get a chance to take that class from her, and she was on my dissertation committee. So I hopefully learned a few things here and there. But all of the logic by which, how do you know what a good item is? How do you screen for bad items? Like, what are you looking for? That's classical test theory. It's a set of rules. How do you know that you have a scale that's reliable or valid, right? And I say those that way because that's the way that people often write about them, as if it's a property of scale that's done. Like, my scale's been validated, done, right? It doesn't work that way, but that's how it often gets talked about. The reality, and something that I didn't really appreciate until much after that class, is that classical test theory is a very, very restrictive kind of measurement model that almost never holds. The reason that it still exists is because people never learned more than that in graduate school, and so that's what they do. And so I'm hoping that you guys are going to be the generation that starts to change this. By the way, here's another abbreviation. PRI means probably. So like, you probably learned about this as an undergrad, or you probably is also an acceptable abbreviation for probably. So classical test theory and other branches are trying to measure what I would say most generically I'll call a latent trait. Vocabulary time. There are a lot of synonyms. A latent trait is any kind of characteristic you're trying to measure that's not directly observable. So my weight and my height, not a latent trait. Get out a ruler, get out a scale. My enthusiasm to teach statistics, that's a latent trait, right? You can observe that I sound really excited, or that I smile a lot, or that I show up and I volunteer to teach these classes, right, live, right? Those are all indicators that I might be enthusiastic. But you can't really know how enthusiastic I am directly. You have to measure it indirectly and make some kind of hope that you've gotten the idea right. So latent traits are the same thing, and you'll see this throughout the slides, but I'll say this here. Latent trait is the same idea as a true score in classical test theory. It's the same thing as a latent factor. It's the same thing as a latent variable. It's the same thing as a latent construct, and it's the same thing as theta in IRT land. All of those words mean the same thing. It's the unobserved characteristic that people differ on that we're trying to measure. That's what this class is about. So we build models. We build models that make predictions about the way that the observed variables relate to each other. If I'm measuring one thing, there should be one pattern amongst observed variables. If I'm measuring two things, I should see two patterns. And the extent to which the data conform to those expectations gives me evidence for whether I'm right. So the observed variables These are the responses, the outcomes, the items, or the indicators. You will see items and indicators interchangeably throughout my slides. I've been trying to be consistent to say indicator, but sometimes item is just what's more common. So those are DVs, is the point I'm trying to make, dependent variables. They can be items like on a survey, like how frequently do you blah 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 blah, or how much do you agree with the sentence. They can be those kinds of items. They can be how fast can you solve this puzzle, and you measure your response time, and you're given a bunch of different puzzles. They can be anything that you believe is the observed manifestation of some underlying tendency, some ability, some trait, some behavior, or not behavior, attitude, something like that. So it doesn't have to be items in the traditional sense. It can be any kind of observed variable. Not all constructs need latent trait measurement models. I don't need a latent trait measurement model to tell me how old I am. I don't need an item that's like, how old were you in 1999? How old were you in 2003? I'm picking years I graduated. How old were you in 2011 when you were tenured for the first time? No, I don't need items, right? I need a birth date. Done. Likewise, there are constructs that don't lend themselves to this kind of an analysis. What's known as formative versus reflective. We'll talk more about this next time. But formative is constructs like socioeconomic status. Those are usually indicated by some combination of your education level, what neighborhood you live in, how much money you make, the education level of your parents. Like those things somehow magically combine to become socioeconomic status. But just because I grew up in Iowa/Nebraska doesn't mean that I got the education that I got, and it doesn't relate to how educated my parents are or where I live now. Like these things don't have to go together. Another construct that's like that is like free time. You can have a lot of free time because you don't have a job, don't have kids, don't have hobbies, don't have friends, right? Like there's all these reasons that you could be not busy. But it's not necessarily likely that those reasons are related. So this class is focused on constructs that are reflective, meaning that the thing exists, right? You have this capability, this attitude, this ability, whatever it is, and that trait causes how you answer the questions or how well you perform on the assessment. That's the kind of models that we're talking about. The trait comes first and it causes the observed variables. That's the belief structure. Okay, with me so far? Question from the audience? Why don't all the constructs need latent trait models? Constructs that are not latent. So the example that I used is height and weight, right? Like I can measure my height with a ruler. I don't need 3 rulers. I can measure how hot it is with the temperature, like with the thermometer. Whether or not those measures are accurate is a separate question. But if a trait is not latent, we don't necessarily need multiple measures of it. That's where the idea was getting at. Okay, does that help? Okay. All right, where's my mouse? Okay, there we go. All right, so I said this already. What do we call the latent trait? And throughout the semester, it's going to get a new name. So this week, it's true score, because we're in classical test theory this week. Starting in week 3, it's factor score. It'll stay factor score, and then it will become theta. And so you will hear me slip in and out of these. I do it accidentally sometimes, but just know that this is all the same idea. Latent trait, latent variable, latent construct, latent factor, true score, theta, those are all the same thing. The differences is in the approach. So classical test theory is predicated on the idea that you have these items, but the only purpose that they serve is you sum them up, and the sum of the items now means something. It's called a test score or a scale score, but it's the sum. And all of the operations that people use are based on the idea of the sum as the unit of analysis. The sum across items is the trait in classical test theory. And that is bad in the sense that items and people are inherently tied together. If you want to measure the same trait with a different set of items, you are screwed because the sum of the items is the trait. They have to stay the same or it's not comparable. There are lots of situations in which you do not want to give the same items. Maybe the items aren't relevant for all of the people. Can I repeat that? Yes. If you have, say, a 10-item scale that measures, let's go with enthusiasm for teaching. Let's stay with that. And I have a 10-item scale. And I give it to a sample of teachers. And then I want to give the same scale to another sample of teachers, but I want to add an item. It's not the same trait because the trait is nothing more than the sum of the item responses. You change the items, you change the trait. So you can't compare. Like, are the teachers in the second sample more enthusiastic? Well, I don't know. They have 11 items and this sample has 10. Like, where do you go with that? I say models, but belief structures that ignore the items, that only deal with the sums, are limited because you always have to have the same items, even when it's not necessarily a good idea. The rest of the semester, starting in week 3, is focused on models that break that tie, where there is a separate estimate of each person's trait that becomes a new predictor variable in the model. It's latent, which means we don't actually have it, but it's still going to be a predictor in the model. And once we have that, once a person's trait is a separate entity from just the sum across items, then we can still compare traits across different samples, even if they didn't get the same items. So you all had to take the GRE to get here, right? Did you all get the same items on the GRE? Nope. Depending on how long you've been in grad school, some of you got an adaptive version of the test where all of the items were adaptive, and some of you got adaptive in blocks. Right? The point of an adaptive test is to not waste people's time with items that are too easy or too hard. The only way that is possible is by using measurement models where how well you did is not the same as how many you got right. It matters which items you got right. Your trait is a separate entity from just the number correct. So latent trait measurement models do that. Okay, question from the chat window. Yep, yes, Kelly asks, so what if we take the average across items? Same thing. Some are average, don't care. It's inherently tied to that set of items. You will hear me say one of my other expressions in this class is an ASU measurement model. ASU stands for add shit up. Like you're just going to add shit up, and that is actually a measurement model, even if you don't realize it. There's a great paper that is just coming out that I added to your reading list about this. Dan McNeish, shout out to him. He writes great papers. Yeah, it's actually a parallel items model when you add shit up, or take the mean. Doesn't matter. It's not necessarily wrong, but it relies on a whole bunch of assumptions that framework doesn't allow you a chance to test. The world of latent trait measurement models allows you to test your assumptions, and it allows you to break the tie between items and people. That's why it's useful. Okay, other questions? Pausing for a moment here to reload. Yes, pro tip, if you're wearing a microphone, you cannot drink your soda without a straw. But most of the instruments are using the sum of the items. Yes. Isn't that interesting? Because that's all people learn to do. What happens in practice is when a scale, an instrument, I know, sad it is, when an instrument gets developed, depending on how long ago it was developed, it had to undergo some kind of psychometric analysis. Psychometric means some kind of quantitative analysis related to its reliability, validity, internal consistency, which is something that we'll talk about later. And if it was built in like the 80s or 90s, odds are good that it's nothing more than running an alpha and doing an exploratory factor analysis and calling it good. If it was built since then, you might get some sort of confirmatory analysis that supports its structure within that one sample or maybe a second sample. And then from there, people are like, so-and-so said this measure is good. Citation, I'm going to go add shit up and put it together. That is a very common but logically inconsistent practice that needs to be stopped. You guys are going to stop it. The techniques that classical test theory, the assumptions that it's based on, all of this stuff is coming up here. It dates back to 1904. Alpha was invented in 1946 or 1951, depending on who you ask. Have any of you been to a hospital recently? You don't have to answer that if it invades your privacy, but just now think about the level of care that you would receive in a hospital. If you found out that your surgeon was using best practices from 1946, how would that make you feel? Not very confident, right? But that is what happens a lot of the time in practice. We have scale scores, and we have somebody who said that they were fine, and so we go and use them as if they were fine. And they may not be fine. We now have the capability in modern computing to do better. In prior generations, that was not the case. And that is why things like alpha were developed, is because if you believe a certain set of assumptions, you can compute alpha with your calculator. You don't need likelihood estimation or any of the things that weren't possible back then. So you have to think of it in terms of the context of what was possible back in the day versus what's possible now. And the ceiling keeps getting higher and higher, but measurement hasn't gone along with it. So yeah, you guys are gonna, once you go through this with that lens and you start reading articles, you will be surprised / horrified at how many things are just glossed over when people add shit up and call it a construct. It's gonna be eye-opening. All right, so several of you were part of my generalized modeling class last semester. Hi. Sarah, not on camera, but a few of you, I know you were there. Things that you learned about regression models in terms of different outcomes. I know that some of you are from disciplines where this is a big deal, like linear regression versus logistic regression and count regression. Like when you're predicting different kinds of outcomes, you need a different kind of model. That idea. Guess what? Same here. If we're going to be predicting item responses, continuous variables that are normally distributed, which by the way, they never are, but whatever, that's a starting point. Measurement models designed for continuous responses are confirmatory factor models. Measurement models designed for categorical responses, what we used to do logistic regression or multinomial regression, those are item response theory models. It's a link function and a different conditional distribution paired with a different measurement model. And you can have measurement models for other things like counts. They don't have special names, but there's nothing that stops you. Stata, GSEM, and M+ are the only software that I know of that have as many options for different kinds of outcome variables. The structural equation modeling is another term that we'll come across. That is correlation or regressions among the latent traits defined by your measurement models. So we're going to have this new predictor variable that is our model's best rendition of the trait. And that trait itself can be an outcome or a predictor of other stuff simultaneously. That's a structural equation model. That's where we're headed, and by the time we get there, it will be anticlimactic. Path analysis is not SEM. Path analysis is using observed variables only. It's just regression. So I'm not going to spend a lot of time on it because it has nothing to do with measurement models. I do have material on that we'll see a little bit of this class, and I can point you to where it is in other classes as well. We will also get a little bit of mediation. Mediation is a big buzzword in quantitative methods. It's regression with a better marketing campaign. That's what it is. Also, we'll see a tiny bit, just a little tiny bit at the end of the semester of moderation. That just means interaction terms, which I promised were not going to be prevalent in this class. So there's a lot of words that you have to learn what they mean, and you will find that the same concept has a lot of different words that goes with it. So where did this come from? The reason why there are so many different words for the same ideas and different notation schemes is because these models really represent two different trains of thought, things that were created for different purposes. Within the realm of psychology, people who study cognitive abilities and personalities is sort of one family of people who developed factor analysis type models and models, classical test theory types of things. They were trying to understand the structure of personality or the structure of intelligence. Like, have you heard of like G? Like the idea of a unidimensional intellect, like Spearman's G, right? Whether there's a G. There's a lot of research suggesting intelligence are multiple, like you can have multiple kinds of intelligence, not just one. All of those debates as to whether there's one kind of intelligences or many, those were debates that motivated the development of factor analysis. On the other side of the spectrum were people in education who had a very different motivation, which was to be able to measure student progress. You might believe that someone has a latent ability, but like, where are they now relative to where they need to go? And so the ability to create tests that accurately measure ability and changes in ability, that's a very different type of purpose. And so we have these sort of two different fields of people working on problems that are related but not talking to each other. And so that is why you have such siloing of terms and the same words or the same terms that have different words to go with them. A lot of this research was conducted, the theories developed before there was computing. And so they're literally just like theoretical papers of how things should be that you couldn't actually test. And so people found workarounds using matrix algebra in a lot of the cases with factor analysis for things that you could actually do. So they did the best they could with what they had. In particular, 1904 is two papers that sort of spanned larger areas. One is showed how to indicate how much of variability in test scores is due to error versus the trait. That gave rise to classical test theory, and the other was how to recognize that there is one trait versus multiple traits being measured, and that gave rise to confirmatory factor analysis. So what is classical test theory? This is where we're starting first. It's this, y equals t plus e. That's it. That's the theory. One thing you'll find in this class that's really funny to me is that all of these models have the word theory in them. Like there's classical test theory, and there's item response theory, and there's generalizability theory, but they're just models. Like we don't say that I have a regression theory model, right? I don't have an ANOVA theory model. You could say that, like, but so don't take the theory part too seriously. Like, but this is just the idea that if you fit an ASU measurement model, you add shit up, that sum score is partly signal and partly noise. The signal part is the T, true score. The noise is the error. Oh, that seems like a reasonable idea. The key thing about this, though, is that it's Y total that we're talking about. We're talking about either the sum across items or the mean, but some kind of composite where the individual information about the items is gone. So that causes a lot of problems. You can't, the sum doesn't know how it was created. So you have to make a bunch of assumptions in order to be able to quantify how much of this Y is due to T and which is due to E. So have any of you had any SEM type stuff before? A few people. Caroline, you're nodding. Does this picture look familiar?
Yes.
Yes. So I've got a box here. That means I have a variable in my data set that's observed. A real thing goes in boxes. Things that are imaginary go in circles. All right. What kind of model would you call this, where I have one box that's caused by two things?
Undefined?
Yeah, very close. Under-identified.
Right.
Yeah. Otherwise known as not possible. You can't have one piece of information and try to figure out how much of two things came out of it. Not possible. So you got to believe. You got to find something else to believe in to make this work. So a big emphasis in this is trying to figure out how much of my Y total is due to T versus E. And the proportion of variability in my total score that is thought to be due to the true score, the trait part, that's reliability. The thing that makes this most limited is that the items are gone. So all of the items must be assumed exchangeable. And if you want to try and improve your reliability, if you want to improve your signal, you just need more items. What kind of items? More. In practice, all items are not created equal. You want items that are really hard, that are really severe, to differentiate among people at high levels of the trait. And you want items that are easy or relatively easy to agree with, if you think of it as an attitude, to differentiate low people and everything in between. None of that is paid attention to here. So all of this is focused on how do we get estimates of reliability using the total score. Underlying this is an assumption that error is a unitary construct, that there's only one kind and more error is bad. You want as less error as possible. The idea that, no, wait a minute, there's different kinds of error and maybe some of them are more meaningful than others. That you can have error that's due to occasions of measurement or raters if you're trying to get outside observations of a behavior or something. That gives rise to what is known as generalizability theory, another theory. There's a class on that you can take at this university. I would call these theories mixed effects models with crossed random effects. Those of you who've taken multi-level modeling with me or will take it, we cover these sorts of models in that class because it's the same idea. You want to be able to differentiate how much variability is due to the signal versus different kinds of noise, so to speak. And so that, I think, is a much more generalizable, pun intended, framework. So a little bit of history to where this stuff came from. Gutman is actually the person who invented Cronbach's alpha. Oops. Cronbach somehow got credit for it. We have a question from the audience. Measurement models allow items to have more weight. Yes. Yes. The measurement models that we're going to learn about, items have at least two different, they differ in two ways. One is sort of the trait level they're designed to measure, and the other is how well they measure it. How well they measure it is going to become a slope in the model. So the models will take into account differences between items on purpose. So we'll get into classical test theory more next time, but just to give you a sense of the history for this stuff is old. I mean, it hasn't changed in decades because this is what could be done in 1945, right? I don't want to take anything away from them because they did the best at what they have. But for the same reason that you guys no longer need a class in how to program your VCR, you probably don't need a whole lot of detail on stuff that doesn't have to be done this way anymore. We have measurement models that are designed to test assumptions rather than just making them. So that's what I'm going to spend more time on. But that will have to wait till next time because my clock says we're out of time. So big picture take homes very briefly. My name is Lisa. I'm here to help you. Don't be afraid. This class is going to cover a lot of stuff, but I hope that it will be useful to you in analyzing your own data. And number 3, everything that you've learned about statistics in other classes, you're going to need for this too. How's that? Okay, then one last question before we adjourn. Sometimes constructs are measured in different scale. How is the best scale to measure a certain construct? That is a good question. How do you know the best way to measure a construct? The best way to test that is empirically. to design experiments that look at the relative accuracy, efficiency, and so forth of different ways of measuring something. There's actually whole fields of study. What is it called? Survey research methodology. There was a program at Nebraska that was about that. There are fields that people study the best way to ask questions and the best way to give response choices. So, but whenever possible, to design an experiment to answer that question would be my advice. So, okay. Anything else before we adjourn? All right, then I hope to see you Thursday. Office hours start now if anybody wants to talk to me. Otherwise, stay well. Peace out.
I think I actually have a question.